Mr. C.N. Raghavendran is a practicing architect and managing director of C.R. Narayana Rao, a family firm of architects and engineers based in Chennai. Born on March 14, 1944, Mr. Raghavendran received his bachelor's degree from IIT Kharagpur and Master of Architecture degree from University of California at Berkeley, USA. Mr. Raghavendran has successfully delivered a wide variety of trend-setting projects for Indian and foreign governments, PSUs, and Indian and foreign multinational corporations. Amongst his notable contribution in the field of design in architecture is introduction of innovation building technology in design and construction, as evidenced in his pioneering work in use of precast and pre-stressed buildings such as in the Jawaharlal Nehru Stadium at Chennai and Cochin. Environmental conscious approach to design of high performance buildings as seen in Ebbings Cyber Tower in Mauritius, which bagged the International Award Intelligent Building of the Year 2005 by Intelligent Communities Forum, New York. This established design commitment is in practice of green building concepts resulted in him being selected as chairman LEED India. He was also the chairman of the Chennai chapter IGBC from 2005 to 2022. The Bureau of Energy Efficiency under the Ministry of Power, Government of India, which has initiated the Energy Conservation in Building Code, has identified Mr. Raghavendran as a resource person for improving understanding and promotion of ECBC norms among stakeholders of the building industry.
Mr. Raghavendran's contribution to architectural education deserves special mention. As member of the AICTE, the All India Council of Technical Education, All India Board of Studies, Governing Council of National Institute of Design, Ahmedabad, and Academic Council of Chennai University, Chennai, he has contributed significantly to the advancement and revamping of the technical education of architecture in India to suit the evolving needs of the industry. He has held offices in several professional organizations such as Fellow of the Indian Institute of Architects, of which he was the chairman of Tamil Nadu chapter in early 80s, and a member of the International Affairs Board of IIA and an International Associate of the American Institute of Architects. Mr. Raghavendran is a recipient of several awards, including the coveted Padmashri in 2011, IIA Design Excellence Award in 1995, the prestigious Architect of the Year Award in 1996, IIT Kharagpur's Distinguished Alumnus Award received from the Honorable Prime Minister of India in 2011. He was also recipient of Boundless Achievement as an Architect of the Year 2023 by PhD Chamber of Commerce and Industry, USGBC Leadership Award 2020 by US Green Building Council, Construction Industry Development Council, Vishwakarma Awards 2019 under the category Achievement Award for Industry Drawing, Indian Institute of Architects Hall of Fame Award 2012, Patterson Cancer Center Award 2003, and from several professional publications such as the Economic Times, ACETECH Award 2007, Construction World Top 10 Architects Award 2007, 2009 and 2010, CWAB Platinum Award of Excellence and Construction World Architect and Builder, CWAB Award 2016. He has received special trophy commendation certificates for professional services rendered by him for Jawaharlal Nehru Stadium, Chennai, and designed for holding South Asian Federation Games 1995, received from the Chief Minister, Government of Tamil Nadu. His works have been featured in several foreign and Indian books, professional journals, and the press. We are very honored to have you, sir. Thank you so much. You can now please take the dais for your presentation.
Dear friends, students, faculty members, namaste, welcome for all of you. Now I have not really specifically prepared anything for this talk. Then I said I'll have to show some works. Therefore what I thought was I will just walk through from the time my earliest days and earliest works till now, not as an exhibition of each project or what is unique about it, but more as what it does to us, the people, to the person who designed it, the people who use it, and to the field of architecture by itself. In terms of what goes to make that the product of design a success, and also the learnings that you pass through in each project as you go along. Over almost about 6 decades of work, I've learnt a lot, and each project is a learning experience, and learning is never an end by itself. You're constantly learning. I mean, that's one desire to learn and work hard will what make an architect a successful architect. So my advice to students is that never stop being curious. Never stop being curious and be inquisitive, ask questions. No matter how stupid you think it may be, it is not a stupid. No question is a stupid question. So please, be free to think. I mean, let your imagination flow, as they say, and be inquisitive about everything. And don't reject anything as undoable. Everything is doable, provided you find a solution for it. Okay, that's why people come to us for designing buildings or building infrastructure or whatever it is, because they see a project, they have a need, they see a project, then they have a land, then they have perhaps money, quite often. Then they have no idea of what to do with that and how to develop a program, how to really start the design concepts, design thoughts, and how the architect will come and work on it, and finally how the building gets transformed into reality so that they can start using it. So the end user has no idea of the process that has gone through the design and so on. Therefore the architects are somewhat not understood in the society. This is another thing that I've seen, is that an architect has to make an extra effort to showcase that he is contributing to the vision of a person who, whatever be the project. It could be a government project, it could be a private project, it could be a house. But a person's intention to create a building and use it through the design of an architect puts a lot of responsibility in architects to understand the whole process. So that's what I think has been the lessons that I've learned in this years of work. So I'll just run through this quickly. Now, see, that's what I said. I call it an experience thing. You really experience the project, experience the persons, experience the user, experience the context in which the building is going to be done, and experience how the performance of the building is going to be, what our intentions are. When we design a building, we say, we've oriented the building, we've done the bedrooms nicely, the windows are positioned correctly and all that, and therefore ventilation is excellent. Now, that's our assumption, but does it really work that way in the end? So that the process is not complete just because we thought something would work and it's put on a design, then it gets on to get into building. So the experience of designing and learning from the process of each design is a continuous process, and most importantly collaborating. The complexity of world is becoming more and more challenging, and the days of a single architect, a master architect or an architect who is working for satisfying his own ego in terms of design. What I design is me, my design, my project. Those days are gone. Today, a building has to perform, and the performance is measurable, and the performance, the architect therefore becomes a little more accountable to his design by the end product must perform. Therefore, when the performance is there, the architect must be open to questioning and open to working together. The requirement also is that you learn a lot. You have to learn a lot, and it's not just be a desk oriented or a drafting table oriented or a laptop oriented kind of work, but it's really integrating. You have to work with other specialists. You have to work with, understand number of other disciplines and number of other processes that go through to make a building. And architect has to be on top of the situation. So that's why instead of being the master architect, you become master of a team of designers and creators of whom the architect holds the prime position. That's the way transformation is happening today. And therefore the pressure on architects, not only just to be, like what the school teaches you, is to become good in one sector of your work. But the final work in your career will be multiple sectors will be there. Actually, we saw the works done by Singh Saab, and you see the integration of all these various specialities into the building. And he's the master of the design. But he has to understand the structure, he has to understand the mechanics of the building, the physics of the building. The building sciences is to be understood. And if he doesn't, then there is no integration of all these services to go a holistic building. So when you say holistic building today, it's not only in terms of context and the person's understanding of what the building gives a feel of comfort, or feel of inspiration or something, but it also has to work for the purpose it is designed. It has to work for the community for which it is designed. It has to work for the site at which it is designed in terms of a built environment. So you have a lot of impact. So this that's what has been. I've just run through some of the sample work. See, I just want to start with one. Next you go. See, I want to show you this work. This is done not when I joined the office, but much before the office, in my father's firm. My father started the firm in 1945 thereabouts, and he has done that. Now, when this building was being designed by him, I was a small boy. I was just sitting in the drawing office, maybe 6 or 8 years old, watching the persons who were drafting it or drawing it, and I was not attracted by this. I was only attracted by the pencil that they're using. The number of small pencils that they'll throw away each day. I used to think that, how can somebody consume? Those days there's no computer, there's no pens, it was just a pencil drawing, hand drafted. So I was just curious that the pencil becomes small, and being frugal. I mean, Indians are frugal. I think South Indians are more frugal than anybody, and therefore you don't really throw away resources. So even if a pencil becomes small, you'll have a pencil holder. I know, like a self-designed pencil holder, and then they'll use it till the last bit. Now, that used to attract a boy, 6-year-old boy. You'll see a tall pencil becoming a small pencil. So I used to go and sit and see what they do on the drafting board. And then I saw lines being drawn. I was curious about what is the meaning of these lines. You draw some lines, write something. What does it do? After some time, you find that it becomes a building. So I was curious and I was fascinated by the thought that a line could become a building. So this transformation is what interested me those days, and therefore, as a small boy, I was exposed to a situation like this in my father designed. What was very common those days, an Art Deco building. It's a classic Art Deco building built in early 1950s, and it was for a Mysore Bank, and it's still there today. And what inside, about 10 years ago, they called us back. Of course, my father was no more at that time. But somebody said, where is the respect for an architect? After nearly 50 years, they called us again back, where they wanted to do up some interiors. When I went there, I saw the building first time as a qualified architect and with some background. The amount of detailing that has gone into the building, the amount of detailing that was considered important, vital. I mean, from the smallest things, from the small cornices to the skirting, to the door, to the handrail, to the friezes, it's remarkable. So that shows that the core of architect is from large to small. You think large, but you must also be able to fit in small things into this, so that the whole and small becomes one. So this is what this building taught me. This experience in this building after 50 years. You realize that no detail can be considered as insignificant. Next, please. See, this is again an early work of CRN. I mean, we call ourselves architect CRN. This is also just as in college. This is one of the large industrial complexes for one of the top industrial groups here. Again, the lesson was, most of these factories were designed climatically, even though the word green was not known at that time. In terms of lighting, for instance, the lighting in the factory, in a large factory covered area, so nicely done, at the same time with heat, just because they understood the orientation, as Mr. Charanjit Saab was saying, that north, south, east, west was understood and was practiced. And technology of using steel. So these two things are, again, are lessons that I think, they influenced me into thinking that climate and technology and architecture are inseparable. Yeah, next please. In fact, my particular attention is to the last slide, bottom right hand side. This again was done in early 60s. The thing that again influenced me was the technology part of it. Look at the roof shell, the roof of the factory building, which had a concrete shell. It's a concrete shell with three-dimensional change in shape. It's doubly curved and precast. To be done in that year, again, it's fascinating. Such things were fascinating to me. Therefore, that later influenced my work also. It's very seriously, the climate and the technology. Yeah, next. Next. This led me to this is one of the earliest works that I have done. It is again a concept of mixing the lighting for an industrial building, large industrial building, and not going for steel but precast. Again, precast is a technology as early as 60s. In terms of slab and the beams were concrete, they were precast and erected inside, so that the construction would become less maintenance requirement and also long lasting, and the fact that it can be done faster. So the orientation of the architecture and the structural element and the understanding of an structure for an architect, the importance of it, I came to realize at that point of time. Yeah, next please. This again taken me to certain elements of structure. See, if you see even the council's book, Council of Architecture's book, on I don't know which section and all that, it talks of comprehensive services that an architect should do. That comprehensive services of an architect covers not just architecture, but it covers the whole range of things, including MEP and structure and all that architect. Now, not that architect is trained to be an MEP engineer, but architect should know enough about MEP and should know enough about structure, so that he is a better integrator rather than a designer of MEP or anything or structure. But the requirement dictates an architect to choose a structural solution. This solution of a long span shell roof did not come from a structural engineer, but an architect, like the architect instructed design which the structural person carries out. So the concept of a shell is again influenced from that earlier factory where you had a doubly curved roof. So this kind of a double curvature gives flexibility, gives rigidity to a thin member. The thickness of concrete will be only 4 inches, but because the shape, it gets the capacity to sustain itself and also sustain the load. I'll show you some other work extension of the same concept later. This again is a reflection of a west-facing building. I used to take that climatology very seriously, and this climatology was also taught very beautifully, well done. And today, of course, you have a lot of software which actually helps you to understand the movement of sun and movement of study shadows and all that. But manually adjusted so that what time and what year, what day of a year, what direction, you cast a shadow on a glass. So long as you cast a shadow on a glass, the glass is comfortable, the indoor is comfortable. An exposed glass is a nuisance. So that concept is developed into this climate-oriented building. Yeah. This is again a building done in Bangalore for Hindustan Aeronautics way back in early 80s. Again, a lot of precast technology has gone into it. For instance, the entire facade is precast. It's precast in different elements, and each floor by floor modules used to be erected in place. And this precasting requires a lot of integration of architectural detailing and integrating with the concept of what how the building is getting wrapped up, and with the movement of sun and wind movements, wind patterns, and so on. And at the same time create a holistic building per se. Yeah, next please. This I'll skip. A lot of high tech. So we used it for a building in Cochin for Reserve Bank of India, the previous line. There again, the challenge was that soil was so bad, you had to go to 45 meters of piling has to be done to reach 45 meters below ground. And I was very uncomfortable doing that 45 meters pouring concrete. So we started exploring the structural designers and soil specialists, an architect-led collaboration in which we said, why not we do precasting of piles? Why not invent a system of joining it so that 45 meters pile is not concrete poured in a blind hole, but it's cast on the ground and driven ground, so that you have a reliable system of this. So this kind of collaborative learning, collaborative experience was an extremely interesting activity for as an architect. Yeah, this is for the IIT Madras Student Activity Center. It's actually a large hall, a multi-purpose hall where sports could be done, sports activities could be done, and also they use it for convocations with 3,000 person capacity seating. And this again is a large span structure, and time limit was extremely small because most of these government projects, they take a long time to get the budget approved. By the time the end date is fixed, so the time left for construction is less, time left for design is less, and the feeling that the government clients think is that the architect will manage. So you reduce the time the architect will manage somehow or other. So this is a situation in which we design the building. Next please. Next. Now, this is a large hall. No steel roof, because steel roof means a lot of sound or acoustics. The acoustics person said you can't guarantee a false ceiling, and we didn't want to do a false ceiling because false ceiling creates maintenance problems. And it's a sports area and also large assembly hall. So it is completely precast, pre-stressed beams were done, almost about 54 meters, and in ranging stuff, and precast roof elements were done. So that sketch, in fact, it's a sketch that I made and gave it to the structural engineer to work on. The beams were pre-stressed in 80s. In fact, in the 80s, pre-stressed beams were used only for bridges and so on. But we brought cross-use the technology into a building, in which the curve section that you see at the bottom is a precast concrete done at the ground level and hoisted in a crane and lifted up. And it's had a curve in both directions so that rainwater will run through. You can see this in elements of this thing. So the shaping of members to give rigidity, it requires a lot of understanding of the material. Materiality understanding is very important for an architect. Next, please. This is again Jawaharlal Nehru Stadium done in early 90s. This is a building again. It was done in 270 days, only because it was completely precast. The whole thing was precast. So the design started with the precast element as a root. Therefore, modularity was very, very important and so on. This is the one in which I don't know whether you can see in this photograph. The roof is a cantilever about 18 meters, 60 feet cantilever for the seating area, and it has to be very thin. That could be done only by doubly curved hyperbolic paraboloid shells with a very thin concrete element. And in a corrosive city like Chennai, it had to be, even today, the thin element has not shown any signs of rust. It required a lot of dialogue and discussions, and we state to the designers, the other service engineers and so on, what we expect, and unless we have a good understanding of their own subjects, we cannot get the best out of them. So this is another example of such thing. At the same time, we maintain our design principles and design thoughts. Next, please. This is a similar stadium in Cochin we did, and both these structures got one got an Indian Institute of Architects Design and so on. The other one got an award for the Architects of the Year. Next, please. Next. This is again a sports infrastructure, more of sports infrastructure done in 90s, 95s. This is for this is an aquatics complex in Velachery. We designed at the same time hockey stadium and tennis stadium, and also the indoor stadium in the team. All the four were done. Again, a lot of precasting and engineering inputs, and integrating both engineering and architecture together, so that people get good, comfortable circulation. A lot of people have to come in and go at a quick time. And their facilities, their sight lines to the sporting area, and overall the constructability of the building. Next, please. So this is hockey stadium. This is a tennis stadium. Yeah. Next. See again, just to show that the architect faces different challenges, different types of buildings. So this mid-90s, we had to, we suddenly it so happened that there were a lot of investments by these foreign car makers, car companies into India, particularly into South India, Chennai and Bangalore. This is the factory building that we did for Toyota Motor Company, and today it is an old picture, but it's multiplied hugely. This again, the importance that here was the conditions of the work environment inside the factory for a worker. Now he works in a condition of hot environment and long hours of work and hard work, physical manual work. Therefore, how do you make it comfortable and easy for him? So this is where the application of concepts of ventilation and how to pre-cool the air for ventilation, and how is it measured so that the performance is ensured. So all this architect guided integration was taking place. See, why I am mentioning this integration again and again is that we learn the core architecture and the colleges here. But later when you transform and get into the career, get into the profession, you face a lot of challenges. And solving those challenges as an architect, you are not fully prepared yet. For you to be ready to face all the challenges, you have to have a thorough understanding of the materiality, the science that goes behind all the principles of design of other services and so on, structure, so that you have you become actually a jack of all trades. But you have separate masters. But as a jack of all trades, you must be able to control and get get what is good for the building design. So that was the exercise why this has happened. In fact, the inside conditions are so comfortable that workers don't leave at all. Yeah. Next. This is one of the earliest IT buildings that we've done. They have special requirements. That one is large span. They want good indoor conditions and good interior workspaces. Workspaces must be very friendly and usable. And because the one is the people who are young, the average age of people who work in such facilities will be about 26 to 30, and they need a vibrant kind of interior and a lot of natural environment, a lot of natural light coming in, streaming and so on. So a very streamlined building which is again oriented and so on, so that you get light being thrown deep inside. Large footprint, but natural light should reach inside. So that is the purpose of some of the panels of glass, but it was controlled in such a way that the glass is always under shade. Let's see. And again, just some random selection. This is the tidal park, which is again one of the first earliest IT parks, the government-sponsored IT parks that came up. And this has spawned a huge amount of IT development in the city. In fact, the whole road on the OMR has become an IT hub. And these again, like what I showed earlier and now, these are unprecedented works. I mean, it's not a conventional work that an architect is trained or taught, but you have to face the challenge of a building. I mean, for instance, at this point of time, none of us had experience of designing an IT building. What is special about it? So a lot of research and analysis has to happen before that to see what is the environment that's required to be created, and then design according to that. So this is hardcore design, hardcore integration of services, and hardcore facilities that make user comfortable and that are energy efficient buildings. In fact, these buildings are all highly energy efficient. So this is the entire heat recovery, rainwater harvesting, and air conditioning system. In fact, the air conditioning system that we used here was one of the most energy efficient systems of that day. Even today it is so. It's not a conventional air conditioning system at all, but it used the differential between daytime temperature and nighttime temperature to adjust in such a way that night times are cooler. So you pre-cool the air, pre-cool the coolant at night time when there is also electric tariff was less. So you spend less money on electricity, consume less electricity, and produce the cooling media at a time when cooling loads are less, and use it during daytime with a gap between these two. The peak load is met by cooling already happening at night, previous night. So that revolutionary concept was introduced here. It is even today working very well. And these are again thoughts that an architect has to sort of keep thinking. I don't think any consultant or anybody in air conditioning would come and say that, look, I can do this. I mean, we analyze, we identify the problem, we have to identify the solution, how do we do it efficiently. So constant curiosity about, how can you do better? What is there to do, more efficiently, and what is there that will also fit with the concept of energy efficient, sustainable buildings. So this constant endeavor is what, and also ability to integrate with other people, work with other people, is what is an important element that in career architects have to be capable of. Next. This is a building that we did at Mauritius. Again, it's Government of India and Government of Mauritius joint project. The Mauritius government wanted to develop their IT capability. Therefore, they came to India, and this Indian-funded, Indian-managed project. All materials went from India to Mauritius, and the advantage was that this opened up the entire Africa as a gateway to Africa for Indian IT business. Therefore, Government of India thought this is a good investment, and in terms of a deal with a friendly government, and it also furthers India's interest in IT. And this is a building in which again the challenge is that creation of ample lighting. In fact, hardly any lighting load comes out of lighting. Electrical load comes out of lighting because there's a huge tall atrium inside that takes care of lighting on both from exterior to interior. So hardly the lights are switched on here. And the air conditioning, cooling, the glass, the high wind loads. In fact, Mauritius wind load is extremely high. So that is again a challenge. The structural engineer told us that the wind load there is 3 times higher than the highest wind load that Indian code wants, because the Mauritius is a small speck in Indian Ocean. Any cyclone or anything happens, that whole city could be wiped out. So their requirement was such high. So we have to, again, the thought of expressing the structure through external bracing, externally braced building. How do you integrate it with architecture? That was the concept that we did. That the bracing is, all these diagonal members are structural elements which give rigidity to the building during heavy winds. Yeah, next. This is the light well that we see the courtyard and view of the lobby. Yeah, next. This is the campus we did for Infosys at Mahindra World City. It's a large, extensive campus for them, and several buildings were there, mostly for software development, research, training, and of course what we see, the top left is a cafeteria for them. That large overhang that you see on the roof actually covers an outdoor dining area for people, and a very extensively landscaped site. So most people prefer to sit outside, even though in a Chennai climate, but just because of that extensive overhang that comes out. Yeah, next please. This is the TCS Siruseri campus. It was also done in mid 2005 to 2010, and this has capacity to seat today seats about 50,000 people, because that's prior to COVID, but after COVID it has all become work from home mostly, and it's a complete township by itself, from transportation. All 50,000 people have to be brought in and taken out, and in buses and all kinds of modes of transport. They have to reach out to the work. They have to do the work. They have shopping, they have dining, they have library, they have training facilities, they have research, and conference facilities and so on. And the concept that we did was to create a central spine. That central spine was nothing but a street, common street. We called it a street because that's almost like a street. So it's like a typical Indian street in which everything happens. And if you see a typical Indian street, from childbirth to death, all activities happen on Indian streets. That's unique. I don't think anywhere else it happens. So that, of course, minus the transport, minus the cars and buses, gives you a lot of livability, lots of dynamism to that space. That space is enveloped by this building, so that people who work here, they become really they feel a sense of ownership in this building. They feel attracted to come and work in the building. Actually, that's in fact, we created a roof at the top, which for two purposes. One is it creates a large hall. Number two, it actually shades the lower room below from direct incidence of solar rays. And we had to create some dynamic forms for this street so that it's attractive. And in fact, this concept is also on a question of a bird going out. The spirit of flying, the spirit of exuberance on the street below. That concept is this central spine was roofed. Yeah, next please. Yeah, next. Yeah, we have different views of the same campus. This is another IT building in Hyderabad. Next, please. This also a building in Hyderabad. In fact, for this also we had to integrate a lot of solar shading devices on the front, and also integrate water bodies and landscaping around the building, considering that Hyderabad is a dry, hot weather. Therefore, any water body creates a microclimate of coolness around it because of natural evaporative cooling. So that extensive use of water body around the building actually cooled the surrounding peripheral areas by a couple of degrees, and therefore the building becomes more comfortable to be within. So the air conditioning also becomes more efficient. These are all platinum-rated buildings. This is another campus that we did in Hyderabad city for the French company, and this also had all the features of green, sustainable principles. And basically, two things govern sustainable principles and making the workspace attractive and likable and healthy to the workers. Indoor air quality, the visual vibrancy of the interiors, all these things coming to make a place more dynamic and interesting to be in, and especially considering the age of people who work in this. This is again a research project for Mahindra Automotive in Chennai, Hyderabad city, and here we had created a large courtyard in the middle, and what you see the bottom left hand side also, all the offices overlook that, and there is a roof pergola going around, which creates a sense of lighting and shadow, and you can see the shadow patterns. And the best is we created an urban forest in this courtyard. So most of the offices face inward rather than outward, and therefore inward facing, everybody feels that they are looking at an urban forest. It is absolutely dense kind of forest there. And lunchtime, everybody spills out into this central square, and this becomes a very vibrant and lively place for break from work for people to assemble and work here. Otherwise, externally, it's almost like a blacked off facility, but it's an inward looking building. Yeah, next please. This is the Grand Chola Hotel at the scene. This is from ITC, and the ITC brand is that they have a Grand Maratha in Mumbai, they have a Sonar Bangla in Calcutta, and this is Grand Chola in Chennai. So it is a traditional architecture is what they require, and therefore this very large facility, and this again in terms of rating, it is in fact US platinum rated US green building, 35%. Yeah, next please. Yeah, same thing, right? Yeah. It's same. same writing, yeah. This is an educational campus we did at CCT for an institute called IFMR. That is Institute of Financial Management and Research. And this is a very, like climatically designed in the sense that that's a very hot place. CCT becomes very hot in summer months. So windows and glass ratios and all that were controlled, and a lot of shading walkways and shading devices were put all around the building, as you can see in the bottom photo, right hand side. And next please. Next. Yeah, these are the internal spaces within that campus, where you have large lecture halls and meeting places and courtyards and overlooking courtyards with activity centers and so on. Yeah, next please. This is Anna Sit Library. In fact, most of you must have seen it. This has, in fact, a lot of consideration is given in terms of improving the natural light for the library reading areas. And it also has an integrated auditorium of more than 1,000% capacity. And this again has an internal courtyard, and also externally where the sun comes from, we had a huge roof projection. In fact, the original intention was to put everything into solar panels, but that project never came through. But it's still capable of taking a solar panel right on top, and that will give but they have other means of power efficiency built into the building. Yeah. Again, different elements of that with some again casting shadows. The casting of shadows on the building was one important element that we felt it would add to the openness of the building. You can free up and open the windows and glass areas if you do shading. Yeah, thanks. Yeah, next. This is the children's section. We created a small tree because typically learning happens around trees in schools, in villages and so on. So for children we created a space, and we created a space for the instant plays and so on, or the small activities together. And the library was also, regular library was also there. Yeah. So this is the building for next please. This is again a software company for IT park. Yeah, next. This is for Amazon. They had a very large software development center in Hyderabad, and here again integration of landscape and building and approach. It's a very small, relatively small size, but the extent of building is quite large. Here again almost about 30,000 people work in this small campus. The cafeteria is like a street, huge street cafeteria is there, reminiscent of our old, if you see traditional cultural events, large cultural events like Aru Remover, Fair Villa and all that. A lot of open dining spaces there, impromptu street vendors. So that concept was used in the dining facility, so that there's an absolute relaxation that when they have their break or lunch break or something. This is how the landscaping integrates the view from the building at all levels, multiple levels. Next please. Yeah, next. This is again one of the recent buildings. For a manufacturing facility for elevators, and the tall building is the test tower. So the test tower had to be not just a test tower, but it had to be something else. So through discussions, we try to create a building which is more than just a figure sticking up in the sky. Yeah. These are one of the current projects that are going on for a university at Cochin, for Chennai Vishwavidyalaya Parishad. And this is an extremely sloping site, and in fact the difference in level between entry to top is almost 80 meters. 80 meters is hillock, all rock. You cannot excavate rock too much because there's a regulation by mine geologists. So levels, play of levels and buildings all round, contours, are extremely important. At the same time, inside, once they go inside, it will be completely pedestrianized campus with a lot of open spaces and meeting spaces for students and faculty to get together. It had living hostels, dining facility, play spaces, all this. Even though it was densely packed because of site conditions of very steep angles and so on, it had to be concentrated, but still integration, careful integration of open spaces and built spaces in a grid, in a loose grid, actually creates a lot of interesting vistas and meeting spaces inside. Yeah, next one. This is the IIT campus at Tayyur, the second campus that's coming up. This is a special purpose campus because the focus is on research here. It's not like generating BTechs and MTechs. It is completely research oriented, and therefore they had different grades of security. Some high-end research happens in the central oval, therefore that's completely protected from other areas. No outsider can get in. They wanted high security levels, accessibility controls and so on. And there's a natural waterway running through. We try to keep the waterway as it is and regulate it in such a way that all the buildings will flow along apart from the oval area where high security works are going to be done. In fact, some of them are very highly national security oriented and so on, defense oriented. Research is going on in the middle, and then you have a street walkway with a water body taking you through the other departments right through. A very user friendly kind of campus where people feel very formally a congenial attitude was to be built into this area. And the scientists and researchers, they don't always work in the lab. They also sit outside and think and work, discuss. So that's why this streetscape with water body was created, which used a natural contour and natural waterway. This is how the campus was done. And one is this. And in the research area, research oval, we had a central spine there also, which is completely, once inside the security, the movement happens through the center, which is completely shaded, so that walking from one building to another in the open is not exposure conditions are not severe. Yeah. These are the buildings that are in the campus. This is typically a research block that you see here with my top corner, where again open spaces, pergolas, meeting spaces, and passing a water body through that, local water body. All the rainwater is collected in a local water body and then it gets collected to the spine canal. Yeah, next please. Okay, that's just a broad summary. But I thought that the experience of running through this integration of disciplines and focus on technology and sustainability, where the factors that I realized was essential for for getting this completion of this. You dream of a building, but your responsibility also is to make it work in the end. So that link is very important for an architect. Not anybody else's work. I design, somebody else builds. You have to stay till the end, and end-to-end service is part of our work. Yeah. Thank you.